NAT Routers Part 2, connecting two or more PCs to the Internet through a single Internet address, and why you will someday need to migrate from IP version 4 to version 6. During the 1990s, as millions of small businesses and families all over the world discovered the Internet, demand for Internet addresses surpassed the expectations of even the most enthusiastic Internet proponents of previous decades. Unfortunately, real Internet addresses are a limited commodity. And back in the early days of the Internet, before it became clear that they would one day be of immense value, huge blocks of these addresses were irretrievably allocated to a few influential universities, corporations, and government institutions. Millions more IP addresses were lost to inefficient allocation schemes as Internet architectures tried to allocate address blocks in patterns that could help them clarify the logical locations and boundaries between separate networks. Back in the early days, as Internet Protocol version 4 became popular, people requesting Internet access got to choose between a Class A arrangement with 16 million Internet addresses, a Class B arrangement with 65,000 addresses, or a Class C arrangement with 256 Internet addresses. Those days are gone forever. As the last blocks of IP version 4 Internet addresses have been gobbled up, even Class C network access is now too expensive for small businesses, and the price is unthinkable for all but the wealthiest of families. If you've already seen the AskMisterWizard.com movie entitled Class C Commercial-Grade Internet Services, then you know that even this smallest of arrangements could provide addressing for as many as 33 million communicating processes simultaneously running on as many as 253 different computers. That was a lot of networking power. A few years ago, as the first Internet Service Providers, or ISPs, opened their doors for business, they all purchased blocks of address space and made plans to sell IP version 4 addresses one by one to families and individuals. By purchasing tens of thousands of IP addresses in a single block and then leasing single addresses month by month to individual homes and small businesses, they expected to generate handsome profits. In fact, they even concocted schemes to lease access to more addresses than they actually owned, by gambling that most of their customers would switch their computers off when not in use. By keeping careful track of computers that were not active from moment to moment, and dynamically allocating addresses from a carefully managed pool, they knew that they might meet the likely demands of 20,000 homes with only 10,000 addresses. This practice has come to be known as dynamic IP addressing, and it's the cause of some extra complexity for small businesses and families using the Internet. The opposite of dynamic IP addressing is called static IP addressing, and you can learn more about static and dynamic addressing from other movies here at AskMisterWizard.com. The customers of these ISPs ended up with just a single Internet address, with the expectation that they could connect just one computer. As you will soon see, however, that single Internet address had hidden power to support all of the computers that a household might ever want, as many as 253 of them. This movie builds on concepts discussed in two other movies that are available from AskMisterWizard.com. They are Simple Routers for Small Networks Part 1, Client Firewalls, explaining operation of a NAT router to protect a single PC, and Class C Commercial-Grade Internet Services, explaining extension of IP addressing beyond individual computers to communicate with as many as 130,000 separate processes per computer. Now, if these concepts are unfamiliar to you, then you really should watch those two movies before proceeding here. You may also find it useful to review our movie entitled Ethernet Delivers the Internet, to become comfortable with the way your ISP encapsulates IP protocol packets inside Ethernet frames for compatibility with your network equipment. All of these movies introduce the subject of routers, with particular attention on the subject of Network Address Translation, or NAT. NAT has been used to expand the number of addresses on the worldwide Internet and postpone the migration to IP version 6, but even with NAT, we will soon run out of addresses. In this movie, we will now examine the way network address translation permits connection of additional computers, all sharing the single IP version 4 Internet address made available by your Internet service provider. The good news is that routers supporting NAT are still available at very low cost, and they still help you beat those internet service providers at their own game. Low-cost NAT routers can still arrange simultaneous internet access for 3 or 4 or more separate computers with existing IPv4 addresses. We'll show how you can even expand beyond that. The theoretical limit permits as many as 253 separate computers, running as many as 130,000 simultaneous communicating processes. After you install a NAT router, as described in the other movies that we've just mentioned, you will probably notice that several Ethernet connections are provided. Most low-cost NAT routers provide about 5 RJ45 jacks for Ethernet connections. One of these would be labeled ISP, or Wide Area Network, or WAN. That one must be connected to your DSL or cable modem. The others expand your local area network, or LAN, for your use through a built-in Ethernet hub or switch. If your router provides only 2 RJ45 jacks for Ethernet connections, you'll have to provide your own hub or switch for expansion. You can immediately connect your additional computers into these extra Ethernet connectors. If you run out of connectors, you can insert additional Ethernet hubs or switches, as described in other AskMisterWizard.com movies from our Ethernet series. As you connect Ethernet patch cables between your additional computers and the Ethernet connectors of your router, you should see the associated link lights illuminate one by one, indicating proper Ethernet connection. If any link light fails to activate as expected, you may need to tinker a bit with the connectors or cable, swapping with a crossover cable, or activating crossover switches if necessary. These details are also covered in our clip called Ethernet Cables here at AskMisterWizard.com. Once each link light is illuminated, you will be able to use any of the communicating applications that rely only on Ethernet protocols. However, before you can use the Internet or use any IP applications, you may need to change the IP address of the associated computer. For your private use, your NAT router will manage a block of special IP version 4 addresses that will never be transmitted across the worldwide Internet. Most NAT routers allocate these from a local block of 256 addresses. By long-standing convention, these usually begin with 192.168.something.something. Usually, this IP addressing is handled automatically. Most routers include a very well thought-out installation process and a special kind of server logic known as Dynamic Host Configuration Protocol, or DHCP, that relies on Ethernet to answer requests from your computers for IP addresses. If your router does not support DHCP, then you will need to go to each of your local computers and manually configure the IP addresses. Consult the documentation that came with your router to learn the appropriate values. If your local PCs are running Microsoft's Windows operating system, then it is very easy to configure an Ethernet interface to request and use an IP address automatically via DHCP. From Control Panel, click on Network and Internet Connections, then Network Connections. A list of all of your network interfaces appears. Select the one that best corresponds with the Ethernet interface you have connected with your router. Usually, it is named Local Area Network. That will immediately display a new frame named Local Area Connection Properties with a list of associated modules under a heading that says, "This connection uses the following items." From that list, select Internet Protocol TCP/IP. A new frame entitled Internet Protocol TCP/IP Properties will appear. From the prominent General tab, select Obtain an IP address automatically and then click OK. Close all of the open frames one by one until your desktop is displayed in the usual way, and thereafter you should be able to access Internet services from any of that PC's Internet client applications, such as your web browser, your email handler, simple Internet games, and etc. In our Simple Routers for Small Networks Part 1 Client Firewalls movie, you saw how a small router could serve as a hardware firewall for a single protected personal computer, assigning it a private IPv4 address and automatically translating its Internet messages to preserve the confidentiality of that address. We showed how that single PC could simultaneously run 2 browser processes. The NAT router automatically learned about those 2 processes and launched 2 corresponding processes of its own to relay and translate the traffic. Here's an illustration of that same NAT router, using the same mechanism to support those same two browser processes in two separate PCs. Let's assume that the PC facing us is running a browser process that has been assigned TCP process number 2020, as in the previous movie. Then, let's assume that another browser process, which just happens to be assigned TCP process number 2021, is running on the other PC. Both of these PCs have private IP addresses that were issued by the NAT router when it was installed, and the NAT router will make sure that those addresses are always hidden from Internet traffic. There could be more than just two PCs addressed in this way, and all of those private IP addresses will always begin with 192.168.0. something in this example. From now on, during this movie, when we refer to one of these private IP addresses, we'll generally use only the last digit. So we'll say that the PC facing us has local IP address 2, and the other one has local IP address 3, etc. Let's further assume that the Internet Service Provider, ISP, has assigned just one single IP address to this household or small business. The ISP thinks we have only one PC, and that it can simultaneously execute a maximum of only 65,535 TCP processes and 65,535 UDP processes. By responding to that Internet address for all incoming packets, and by translating the IP addresses of all outgoing addresses to that Internet address, the NAT router deceives the ISP into thinking that it is the only PC at this location. Even though that router doesn't have as much computing power as the array of PCs it is protecting, it doesn't need to be very smart, because it is set up astride the network path as a kind of a middleman in all of these conversations, so that for each of these message exchanges, it always learns exactly what to say from the PC processes for which it acts as a kind of a proxy or agent. It doesn't need to actually understand those messages. It just readdresses and relays them. It simply discards any incoming messages addressed to local PC processes about which it has no information. When the browser process inside the first PC at local IP address 2 needs information from a web server on the Internet, it formats the request according to the TCP conventions of the Hypertext Transfer Protocol and addresses the TCP data to process 80, which is the usual process ID for web servers. The IP packet is then inserted inside an Ethernet frame addressed to the NAT router and sent on its way. When that data arrives at the NAT router, the Ethernet frame is discarded and the IP4 packet is examined. The IP addresses are temporarily preserved in that router, and then the IP packet is discarded, permitting examination of the TCP data header. From that TCP data header, the NAT router learns that the PC with local IP address 2 is running a TCP process that it has named 2020. The router then starts a new process of its own to relay that traffic, configuring it with the appropriate local IP address 2. For our purpose in this discussion, we will assume that the NAT router assigns TCP process 3000 to this new process. Accordingly, the reference to process 2020 is replaced with 3000. The destination process ID out on the Internet, port 80, is left unchanged. The modified TCP data is then wrapped inside a new IP header, still addressed out to the web server on the Internet, but replacing the source address with that of the router to satisfy the ISP. That IP header is then encapsulated inside a new Ethernet frame and sent on to the Internet through the cable or DSL modem. Eventually, the remote web server responds with new data for the browser. When that data arrives at the NAT router, it is of course encapsulated inside an Ethernet frame from the cable or DSL modem. The Ethernet frame is discarded to reveal the IP packet addressed to the router. The router temporarily preserves the source IP address, discards the IP packet, and examines the TCP data inside. The router can see that the TCP data inside is directed toward its process number 3000. The router knows to send that data to process 2020 on the PC with local IP address 2, and so it updates the TCP header accordingly, wraps it inside a new IP packet addressed to 192.168.0.2, wraps that into a new Ethernet frame for that PC's Ethernet hardware and sends it into the internal network where that PC can pick it up, stripping off and interpreting the frame and packet and TCP information to ensure that the web server data is displayed by the appropriate browser. The same mechanism is used when the browser process 2021 in the other PC with local IP address 3 requests data from some other web server. By monitoring the outgoing requests, the NAT router is able to learn of all of the communicating client processes in all of the computers, launching proxy processes of its own to handle the corresponding incoming responses. When handling these two browser processes in two separate PCs as shown here, the router's process handling is almost exactly the same as when managing two browser processes inside a single PC, as shown in our NAT Router firewall movie. It really doesn't matter how many PCs you use to host your processes. The original IP address issued by your ISP anticipated as many as 65,535 simultaneous TCP processes and another 65,535 simultaneous UDP processes. Of course, those numbers represent the theoretical maximum. An inexpensive NAT router will run out of memory when asked to manage more than a few hundred communicating processes, but that should be enough to support all of the PCs likely to be needed by a household or home business. A more expensive, business-oriented router can handle tens of thousands of processes in this manner. Once the NAT router learns of a communicating client process in any of your PCs, it remains prepared to handle the associated network traffic, relaying it and translating TCP, UDP, and IP address references as necessary, so that the ISP thinks everything is coming from a single PC addressed by the single original Internet address. The router remains prepared to handle each communicating process for an appropriate period of time, until the communicating processes negotiate an orderly disconnection or until a reasonable period of inactivity indicates the end of associated workflow. Weaknesses. This system works very well for most situations, but it does suffer from three generally manageable weaknesses when compared to an old business-oriented Class C Internet connection as described in our movie by that title. Firstly, the number of processes that can simultaneously exchange data between the worldwide Internet and all of the computers in your local network is limited. The theoretical limit is reduced from 33 million processes down to 130,000. The practical limit, determined by the processing speed and memory capacity of your NAT router, is on the order of a few hundred processes. Secondly, if you are going to host server processes such as web servers, FTP servers, voice over IP servers, or multimedia servers or game servers out on the Internet, you will run into additional limits. You will need to go through a manual configuration exercise to tell your NAT router about each of your servers, and only one server of any given type will be able to use the well-known, usual and customary TCP or UDP process, or port, that Internet clients will expect to use when communicating with you. You can certainly run more than one server of any given type, but the extra ones will either have to be configured to use unusual port numbers, or they will be isolated from the Internet. This subject, known as port forwarding, is explained elsewhere here at AskMisterWizard.com. A third restriction: a few applications are just not compatible with NAT translation because they need to exchange additional IP addresses or port numbers deep inside their own TCP or UDP data, where a low-cost NAT router cannot identify or translate them. These are generally rare and obscure applications, but if you run into one of them, you'll have to abandon it in favor of some more compatible replacement. Conclusions. A low-cost NAT router permits you to give Internet access to more than one computer in your local area network. In a typical situation, 4 to 10 PCs can be supported. Each of those PCs can run almost any combination of client processes to access servers on the worldwide Internet. Most peer-to-peer applications are designed to behave like clients in this respect, and so they will also be supported. Server processes can also be supported, but they will require manual configuration and some compromises may be necessary. Eventually, the Internet will run completely out of IP version 4 addresses, and at that point, newcomers will be forced to use IP version 6 addresses. It is likely, however, that old IP version 4 addresses can continue to work. We appreciate our many YouTube viewers. However, if you are trying to find our videos only on YouTube, you are missing out on a lot of our very best content. We have thousands of informative video clips like this one, and it can be difficult to find the others in proper sequence. On our site, these clips are also accompanied by related links, related text, still images, audio recordings, question and answer forums, and advertisements from carefully selected vendors that understand these issues and want to help with their products. Please join us there. We appreciate your support. From YouTube, it's easy to find our site. Just click on the prominent link at the beginning of YouTube's descriptive text. Thank you.